Hi guys, welcome to question 3 of the 2018 Aqueous examination paper. Let's wrap up this exam in this video. Right, question 3. Write down the solubility product for AgCl. So this is just, if you're not sure how to do this, AgCl solid partially dissolves into the ions of Ag plus and Cl minus. And how do we write the Ks? Because it's equilibrium, we write the products divided by the reactants, but because the reactants is a solid, we don't need to write it, Ag plus, Cl minus. Why does the solubility of AgCl decreases when a small volume of silver nitrate, which is AgNO3, is added to a saturated solution AgCl? Because you have got a common ion. In AgNO3, this will completely dissolve into Ag plus and NO3 minus. You have Ag plus here, you have Ag plus here. This is a common ion. Because of the common ion, if we go back to the equilibrium that we did up here, because you already have some Ag plus, so this concentration is already high. So what does it mean for the equilibrium? Because you already have too much of the Ag plus ions, the equilibrium will shift this way. The system will shift to the left to use up the extra Ag plus. As a result, you have less AgCl dissolving. Okay, so the solubility will decrease. Okay, so this is a merit question, I believe. It's a common ion, increase in time, shift towards the left to reuse up some of the extra Ag plus. Exactly what I said. Therefore, you have more AgCl and solubility decreases. Okay, that should be easy enough. Next one, show by calculation whether precipitate. So whenever you see whether precipitate, you need to compare Ks versus ionic product. Okay, so remember the analogy I gave. Ionic product is your rank score. Ks is the university entrance. If you're bigger than it, you precipitate, you leave. If you're smaller than it, you stay. You don't beat the rank score and you stay at school for another year. Okay, so I'm not going to go through that analogy again. Just watch my 2019 video for this particular question. Okay, so 17 moles of Okay, so it's Ag. Let's get rid of that, so just in case you can't see. So we're deciding if we are going to form AgCl, because you got AgNO3, you got AgNO3 mixed with NaCl. So with AgNO3 you have Ag plus and NO3 minus. In your NaCl you have Na plus and Cl minus, and they are asking you, is the Ag plus and the Cl minus going to hang out? They're going to ditch their partner at ore and they're going to hang out with each other to form the precipitate of AgCl. That is the question. So to determine this, we need to know the concentration of these two ions specifically. So if you want to skip all of this thing I did over here, just look at the Ks. All right, so if you look at AgCl, you're like, what? I don't have any AgCl. This is AgNO3, this is NaCl. Where did the AgCl come from? Well, we are asking you, are we going to see the precipitate of AgCl? So you need the Ag plus and the Cl minus concentration. So the Ag concentration is here, 0.022. The Cl minus concentration is here, 0.055, but that's not done because you've got different volumes. The volume has changed, so you need to dilute them. This used to be 70 mils, but now it's 120 altogether. This used to be 50 mils, but now it's 120 altogether. And then if you did the dilution, this is going to be 0.0128 moles per liter. Please add the unit, I ran out of space. This is going to be 0.0229 moles per liter. So how do we figure out the ionic product? Well, QS, the same thing. How do we figure out the ionic product? You figure out the same way as you would calculate the Ks, because you'll be unfair if you go to university, if your rank score is calculated differently to someone from a different high school. That would be extremely unfair, wouldn't it? So Ks is calculated using this equation as well, so IP will be calculated using that particular equation. So Ag plus is going to be 0.0212, don't do what I did in the exam, writing numbers in the other way around. That will be the most miserable thing ever. Okay, so write that in, and the answer will be 2.94 times 10 to the power of -4. There's no unit here, don't put anything here. Now you compare the IP versus the Ks. Your IP is bigger than Ks, This is a bigger number, hence you will see a precipitate. Yes. Okay, so you can leave school. Next one. Predicting precipitate. That's when you see the word whether precipitate would appear or not, go straight into that particular method of calculating, then you won't be wrong. 5.11 grams of sodium methanoate is added to 125 ml of this to make a buffer solution. Assume there's no pH and no change in the total volume. Thank you. This is actually a really important clue. pK is given, Ka is given. pH range over the resulting solution will function as a buffer. Thus, I talked about in question 1 or question 2, I can't remember. The buffer region is pKa plus minus 1, which is going to be between 2.74 to 4.74. How do I know that? Because pKa is 3.74. Next part, calculation. The pH of this buffer is 4.50. Okay, so this is where you need to use the buffer calculation. So how do we do the buffer pH? This is where you can either use one or the other. I personally like, because we got given the pKa, I like using pH equals pKa plus log base over acid. Okay, so show the calculation that so the final answer is 4.50, but we're not supposed to know that. Okay, so what do we need? We need the concentration of base, we need the concentration of acid. What is the base? What is the acid? Because we know pKa, that's given. Which one's the base? And the one that I'm highlighting, that is the base. And methanoic acid, this is the acid. Okay, so this is CH, this is HCOONA, which is HCO minus, same thing. This is HCOOH. What is the concentration? HCONA, what do I know? This I know there's 5.11 grams. If I know grams, I can figure out the mole, can't I? So how do I convert this to moles? N equals small m divided by big M. So this is going to be 5.11 divided by 68 grams per mole, which is given right here. Remember, every number that we give you in chemistry, you need to use them. Okay, and this will be 0.0751 mole. So that's a moles. Let's look at this HCOH. So this is right here. I got 125 mils of 0.105 moles per liter. Now you can do this in two ways. No, let's not do that. Let's just stick with the easier method. If I got the moles here, we need the concentration, don't we? Because this concentration is already given. The HCOH concentration is already given. So how do we figure out the concentration from the moles? They said that there's no change in the total volume, so the volume is 125 mils. So the concentration equals N divided by V. So it's going to be 0.0751 divided by 0.125 liters, which is 125 mils, and this is 0.601 moles per liter. That's why this particular clue is really important. No change in the total volume, so you can use the 0.125 from the question, because that's how much liquid you have. Okay, so my HCOO minus concentration is 0.601, and then HCOOH concentration, which is just in the question, which is 0.105 mole per liter. And now we practice the magic of substituting numbers into the equation. So pH equals pKa. What's pKa? 3.74 plus log base, which one's the base again? 0.601 divided by the acid, which is 0.105. And I'm going to crunch these numbers in my calculator. 0.601 divided by 0.601 divided by 0.105, and then we log this answer, then plus 3.74, then your answer should be 4.503 significant figures. pH don't have units, so don't put one there. Now if you look at the marking schedule, they probably have done it in a really confusing way, so that's probably why you're here. That's how this is the equation I tend to use. If you don't like using this equation, you can use H3O plus equals Ka times log acid over base. It's the other way around. Okay, this is one more method, one more calculation step, because once you figure out the H3O plus, you have to negative log. What is the point when you have an easier method like the pH equals pK plus log base over acid? Okay, so that's that question. Looking at the last one, evaluate whether this buffer will be more effective against small volumes of strong acid or strong volume of strong acid or base. Okay, so let's look at the pH. Your pKa is 3.74. So pKa is 3.74. pH is 4.50. Now just remember, remember the buffer region. The buffer region is 2.74 to 4.74. So our pH of 4.50 falls in the range, so it's a buffer. Okay, but just remember, if pH is larger than pKa, this means the base concentration is going to be stronger than the acid concentration. This is just going back to the equation, because if I mean pH equals pKa plus log base over acid. Yeah, this is to do the pH of the buffer depends on the ratio of base divided by acid. If you have a larger pH number, that means this log base over acid must be a positive number. The only reason for that to be a positive number is that the denominator on the bottom is a smaller number than the top of the fraction. Okay, so that's just mathematics. If you don't want to go if you're not a strong mathematical person, which is again probably why you're here, because this whole topic 95% is math, involves mathematical calculation. Just remember, if the pH is bigger than pK in the buffer solution, so the buffer of the pH of the buffer is bigger than the pK of the buffer, then the base concentration is stronger than acid, vice versa. Okay, so what does that mean? If the pH, in this case our pH is, so that means we have more base, so that means in the buffer there's more base than acid. And what does that mean? That means this is more effective against acids. Why? Because you have more base. You have more base to neutralize them, and that's essentially all there is. Okay, so if you, it's about quantity. If a buffer solution has both acids and bases, yeah, and they're supposed to resist pH change when you add an acid or a base, but they can only do that to a certain extent. If you have more bases in your buffer, obviously you have more quantity. You have a higher quantity, higher concentration on the base, which can resist more addition of the acid. Okay, and let me just quickly show you the answer. So pH is, so you have a buffer, but pH bigger than pK, that means you have more base than the acid. That means you have more effective buffer against a strong acid. Okay, so I hope this recording is helpful. Again, large number of my viewers aren't subscribed. Please subscribe, leave a like button. I'm really trying to push for one video at one exam paper per day, because we're literally counting down to 27th or 26th of November, 14 days, one video, one exam per day. So that might take us all the way to 2017, and that should be enough support from me. And because after that, I don't think any of you will watch this for a very long time until you go on to next year level. Okay, but other than that, subscribe if you haven't, and yeah, and I'll see you guys next time. Bye bye.